Hi, I'm going to demonstrate to you about EnVision's e-learning tutorials. These are self-paced multimedia tutorials developed to teach fundamentals of petrochemicals, refinery, and boiler operation. So it has its own learning management system called Web Tut Administration. This is primarily used by instructors to set up test criteria. They can monitor students' progress and look at all the detailed statistics about usage of tutorials. For trainees, the tutorial is available in different languages, and they're originally developed in English and then translated, and audio is also dubbed in different languages. So I'm going to use English as an example. Let me log in. So we have acetylene converter for ethylene unit, alkylation unit for refinery, amine treating unit is used for gas processing as well as refining units. Blending is gasoline and fuel oil blending used in refinery. Boiler teaches fundamentals of a drum type boiler. Catalytic reformer semi-regeneration, we're in the process of completing CCR. Then we have a compressor with lube oil and seal oil system. We have crude distillation unit. We use distillation using dipropane as an example to teach distillation. Ethylene heater, this is for an ethylene unit. FCC unit for refinery. Typical furnace for all chemicals, petrochemicals and refinery operations. Hydrocracker, HDS, and hydrogen unit also for refineries. Then we have two process control, one on basic and advanced process control. They teach fundamentals of process control, more for process control engineers. Process fundamentals is a small tutorial that teaches the overview of refineries, primarily for technical colleges. Then we have a pump module for pump, talks about operations as well as maintenance. Then for sulfur recovery, Claus process and Scott process, these are used both in refining as well as gas processing. We are also in the process of developing 5 to 6 additional modules to complete the refinery, and later on we'll be working on some more fundamental modules. So let me take boiler as an example and demonstrate to you. So it has 9 chapters. So if I click on first chapter, it gives me chapter 1 details, overview, boiler components. It goes into details of component. This is we're using drum type boiler, and purpose is to use principles to teach in boiler. Can be used in a refinery, petrochemicals, or power plants, but the principles are the same. Boiler performance, here we're talking about principles in terms of burner characteristics, stoichiometric combustion air, the use of dampers, air registers, fuel characteristic, the calorific value and heating value of fuel gas and fuel oil, how it can affect the air requirements and boiler performance. Then we go into boiler control system. This is typical. You're trying to control the drum level using 3-element drum level control, steam temperature control. Now pressure control and the rest is typical boiler controls in terms of pressure, cascade control, or rather feed forward signal from the steam, followed by cross limits or lead lag controls for air and fuel, and then they control the respective fuel oil or fuel gas or both. Talks about oxygen controls, and then we talk about boiler trips and interlocks and purging logic. Then having explained the boiler process and the controls and interlocks, then it's time to talk about operations in terms of pre-startup, how do you start up, shut down, and post-shutdown operations. Then we cover some normal operations and cause and effect. Talking about some emergency or troubleshooting related issues, low steam drum level, rupture of heating tubes, flame out of all burners, and some other operating considerations like flame color. What does the flame color indicate? If there's a leakage in the tube or soot deposits, how do you do that? Especially the oil-fired boilers. If there are measurement errors, what could possibly how it could affect the boiler controls. So I'm going to play one or two clips to give you an idea. So let me talk about say types of boilers.
Types of boilers. There are several types of boilers, and their structure varies widely depending on their capacity. Boilers can be classified based on mode of the water flow and mode of air and flue gas flow. Classification based upon water flow. In a boiler, the water can be heated in many ways. In some boilers, the water converts to steam as it flows from inlet to outlet in heating tubes. This type of boiler is called a once-through boiler, and it is normally operated in the supercritical pressure region. It is mainly used for large capacity power plants. In another kind of boiler, the flue gas flows through the boiler tubes, which are submerged in the water. The steam is generated by transferring heat from the hot flue gas in the tubes to the water on the shell side. This type of boiler is called a fire tube boiler, and it is used for small to medium-sized industrial boilers. The most commonly used boiler is called a drum-type boiler. In this boiler, the water enters a drum. It then circulates through the heating tubes to produce steam. The steam from the drum is further heated to higher temperature by the hot flue gas.
Okay, so let's take a look at some one or two more sections.
Drum, water circulation, and heating system. This section consists of the steam drum, the mud drum, the downcomer, and the heating tubes. Steam drum. The steam drum is located at a higher elevation in the boiler and is connected with the mud drum located at a lower level with tubes. The feed water from the de-aerator enters the steam drum, mixes with the hot saturated water, and flows down through the tubes into the mud drum. The water from the mud drum circulates back to the steam drum via various heating tubes, where the water is partially converted to steam. In the steam drum, the steam is separated from the returning water-steam mixture. A baffle plate is placed near the return nozzle to enhance separation.
What we're trying to do here is, we have an audio, it has a script, and, we use animation, and we show key text that are important. This way, an end user can hear the script in terms of content. They can see the animation, look at the key text, and build a mental model about different parts of boiler operations controls. And this would be a first step, self-paced mode, where they can learn the fundamentals. And then after this, they have two choices. They can go to unit-specific boiler classroom training at a plant, or they can use a boiler simulator practice operations. So ideally, you learn through the simulator tutorial and then practice what you learned in the tutorial on a simulator. This way it reinforces everything you have learned and helps you understand the complex dynamic interactions and controls. And after this, then you would go to your boiler specific training, which would be next step. It could be classroom, it could be walkthrough in a unit, or it could be GSE's full mission simulators. Okay, let me maybe show you something about, say, pressure control.
Steam pressure control. The steam pressure is subjected to continuous changes due to continuous variations in the boiler load. As the steam demand increases, the steam pressure decreases. And when the steam demand decreases, the steam pressure increases. Hence, the main objective of the boiler control strategy is to maintain the steam pressure at various steam demands. The steam pressure is controlled by manipulating the amount of fuel burnt. As the steam pressure increases, the fuel flow is reduced to produce less steam, and the steam pressure is brought back to the design value. Similarly, when the steam pressure decreases...
Let me pause here. As you can see, tutorial is fairly complex. It's trying to explain in a simplified way. And I'm going to quit the tutorial, and this time I'm going to start the simulator and use boiler as an example. So I'm going to use US units. PSIG is degrees Fahrenheit. However, we have available in bars in Celsius, kilograms, centimeters, or Celsius, or kilopascal, in different units and temperature. So here is the simulator. I'm clicking on a running person icon to start the simulator. I'm going to run acceleration mode. So we have demineralized water coming in, deaerator. The pressure is controlled by controlling the steam flow. The level is controlled by controlling the inlet demineralized water. We have feed water pump, turbine driven, motor driven is a backup, minimum flow circulation, and followed by we have a low pressure switch. So on a low pressure, it'll do an auto start for a backup pump here, or you could do a manual start by switching on the pump. From economizer, we come in, part of the water goes to a temperator, rest goes to the economizer, feed water flow control valve, drum. We have a block valve and a bypass valve that can be manipulated. And purpose here is in the event the control valve fails or a transmitter fails, they can use block or bypass valve to rectify the situation. Then from drum, we have downcomer, mud drum, water walls, and then saturated steam, primary superheater, we have a temperator, secondary superheater, and then the final steam temperature is controlled by controlling the water flow to the temperator. We have FD fan, air preheater, air going into the firebox. And then the steam goes to high pressure, medium pressure, low pressure steam headers. And we have a letdown flows that control the respective steam headers. And we control the steam demand, using these, because steam can be used in different locations. So if I want to increase steam demand from 25 to 30, I will just increase the set point. Okay, while as I increase the set point, what's going to happen is that the drum pressure set point was 600. The drum pressure is going down, and as drum pressure goes down, it's going to go through advanced control. It's going to increase the airflow and the fuel flow. So let's look at the fuel system. We have a pilot, trip valve, main fuel trip valve, main fuel gas control valve, and ultimately there's a low pressure override that maintains minimum fuel gas pressure. Then we have 4 vertical burners. I can click on individual burners. I can adjust the damper. We have igniters, pilots, main fuel line. I can change the fuel gas. That's how we like the burners. You operate the burner, and everything is done by yourself. We lay down advanced control strategies. So we have 3-element drum level control, where steam drum level, boiler feed water, steam flow is a feed forward strategy, and then we have boiler feed flow controller. Then boiler controls are here, which is the high pressure steam controller, steam pressure controller, steam flow as a feed forward controller, that's your boiler demand. Then you have cross limit control. So this one is fuel gas cross limit control. It measures the air and converts from air to fuel, and that's the maximum fuel it can burn. So it takes a low selector. That becomes a set point for the fuel gas flow controller. Then the boiler demand signal gets converted to air demand. Again, you have a cross limit. So you have fuel gas, it converts fuel to air. That's the minimum air required for complete combustion. And so there is a high selector here, and then it becomes set point to the airflow controller. Then for O2, we have a bias here. Instead of bias, sometimes there can be a PID controller. So the idea here is keep the controls fundamentals, and one can actually see every controller's output, inputs, and understand how the boiler works. We have trips and interlocks. So we have low fuel gas pressure trip, emergency shutdown on a low steam drum level, a low airflow. In this case, both the fuel gas and pilot are tripped. And then we have purging logic. Once the boiler is tripped, you must meet the purge permissive, and you have to purge the boiler before you have permissives to open these trip valves. So it also has alarm summary. We don't have any alarms. We have group display, and actually we can see how this is the boiler inlet airflow. As I increase the steam load, you can see the airflow also increase automatically. Or I could put this in automatic and say, hey, I want to increase the airflow. So you can see as I change the set point, which is the red, how the controller output and PV changes. And I can put this back in cascade. Then here are some alarms that came in. It got cleared. If I acknowledge it, it goes away. We have historical trends. So we can zoom, pan. We can look at values. And then all the key variables are trended. So actually pretty much we are trending every single variable up to 16 hours, and that's more than sufficient. And you can see how the graphics are very quick. We have different initial conditions. We can set to cold startup, and in this case it's empty, and basically learn how to do a full startup. We have all the moves that I made are logged here in terms of various alarms that came in. I changed the set point, etc. So this is a log of sequence of events, useful for troubleshooting and also as a record. We have full online help. So all the procedures, exercises are basically here. So one can look at these procedures and learn how to start up the boiler. We have battery limit conditions where you can change ambient temperature, fuel gas composition, and study the effects on the boiler. And then we have for troubleshooting, we have malfunctions like loss of demineralized water, loss of fuel gas, burner tip being dirty, control valve fails open, close, transmitter drifts, fan failure, pump failures, leaks. So these are different, troubleshooting, equipment and controls that they can learn about troubleshooting the boiler. So that's a very quick overview. And, if I were to trip the boiler, in this case, we can see we got an alert saying the boiler trip, gives you probable causes, suggestive corrective actions. From these, I can, between this and the log, I can pretty much determine what caused the interlock, and we can look at the trends, we can look at group display, alarm summary, and try to recover it. Once the boiler trips, we got to bring it to the safe condition. We need to quickly come to the control valves, maybe set them in manual mode. In real life, probably the valves automatically go to manual mode. Now, maybe it is written based on a program in DCS. Here you do everything manually. Goal is to learn. Okay, sound that you're hearing at the moment is probably the backup fan came up because the boiler tripped, the pressure is going down, and it's basically saying I need more fuel, more air. So that's, it asks, air is basically maxed out, so that's why the second backup fan started. And actually, one of the first things I should have done was I should have isolated these steam to demand, because otherwise, this will just depressurize to atmospheric pressure. Okay, so that's a brief overview. And some things that we do, like in different languages, like if I were to do, for example, in Spanish, the text here is in Spanish, malfunctions are described in Spanish. If I look into help, all the guides are in Spanish. So we use selected different, selective translation from end user's point of view to make it very easy. Okay, so that's a quick overview about boiler tutorial and a boiler simulator. If you have any further questions, please contact GSE representative. I will be happy to discuss this further. Thank you.